In P9, we are going to solve inequalities, and we are going to learn about interval notation, which is the main new thing today. Inequalities should feel like review from Algebra 1, but we're going to recap what inequalities are. And solving inequalities is going to be just like solving equations. But here's our inequality signs. Inequality signs look like these. So we're just going to put a couple quick examples underneath each inequality sign and make sure that we understand what they mean. This first one is a less than symbol, and an example would be x is less than 5. I just made that number up, but if I head to my number line, I would put a 5 somewhere in the middle of my number line, fill in the rest with things above and below, and we want to shade everything that is less than 5. So we want to focus on numbers that are smaller than 5, like 2, 3, 4, all the way up to 5. And in the past, you guys might have put like a dot at 5 or an open dot at 5. But today we're going to learn interval notation, so I'm going to show you what symbol we would put at 5, and we'll go over this in a few minutes in the video. So we're going to put like one parenthesis symbol at 5, and then I'm going to move on to the next one. This next symbol is less than or equal to, and my example is going to be x is less than or equal to 5. I'm just going to continue using 5, so my graph is going to be filled in the exact same way. And I'm going to shade everything less than 5 all the way up to 5, but this time, because of that equal to part, I will be using a different symbol, which, like I said, we will go over in just a few minutes, but this would be a bracket. It's kind of like a parenthesis, but with sharp corners. The next symbol is a greater than symbol. An example would be x is greater than 5. So again, 5 in the middle, but this time we're going to shade numbers that are greater than 5, so we'll shade the other side. And the symbol that I'll use here is going to be a parenthesis again, but this time we're facing the other way. For the last inequality, it's going to be greater than or equal to, and example would be x is greater than or equal to 5. So put 5 in the middle, shade above. But because of that or equal to portion, we will use a bracket, which again is like parentheses but with corners. And that brings us to interval notation, which interval notation is brackets and parentheses. We're going to use brackets, which are the ones that have sharp corners, when something's allowed to equal a value. So if you see the equal to part, we'll use a bracket. And we're going to use a parenthesis if it's not equal to. Let's look at the examples above before we put an example down here of what interval notation is going to look like. But basically, interval notation will use brackets and parentheses, and we won't have to graph or use a number line or anything like that to write our final answer. So if you take a look at the very first one, x is less than 5, which means x could be anything below 5 all the way to negative infinity. So when I'm less than, I'm headed towards negative infinity pretty much, because I could go down forever. And you can never equal negative infinity, so I'm going to put a parenthesis next to negative infinity, and I'll do it in red so it's easier to see. Because remember, parenthesis means not equal to, and you can never equal infinity. So interval notation would be just putting those things in order on the number line, lowest comma highest, with parentheses or brackets. So let's do the next one. The next one is also less than, so we're headed towards negative infinity. And it's the same thing. You can never equal negative infinity, so we'll put a parenthesis next to it. And then we go as high as 5. You're allowed to equal 5. There's already a bracket on my diagram, but because we can equal 5, we would use a bracket next to 5. So this would be interval notation for that next one. Now let's do a greater than one. In this example, x was allowed to be anything greater than 5, and that is anything all the way up to positive infinity. X can be 100, x could be 1,000,000, x could get higher and higher and higher all the way to infinity. And remember, you can never equal infinity, so we'd have a parenthesis next to that. We always write our interval notation as the lowest comma highest. The lowest x can be as 5, the highest x could be as infinity. And remember, we can't actually equal 5, so we would put a parenthesis there. The last one, x is greater than or equal to 5, which means x can be 5, all the way up to infinity, which x will never equal infinity. Our interval notation looks like this. The lowest would be 5, the highest is infinity. You can't equal infinity, so use a parenthesis, but you can equal 5 because the problem says greater than or equal to. So that's an example of interval notation. So let's do one more down here where we wrote interval notation. If I gave you something like 2 is less than or equal to x is less than 5, what this means is x is between 2 and 5. And x is also allowed to equal 2 because we have a little equal bar there. So we would put lowest comma highest. Lowest always goes first. Highest will go second. It's always going to be in order like that. Lowest comma highest. The lowest number x can be is 2. The highest x can be is 5. We are allowed to equal 2 because, again, we have an equal bar there, so I'd use a bracket. But we're not allowed to equal 5 because there's no equal bar next to 5, so I'd use a parenthesis. This would be interval notation for this example. And then the last thing we want to fill in, this is not new. You maybe just didn't know what the name was for it, but set builder notation is inequality notation. It's what we've already been using. And it uses those signs greater than or less than, equal to, etc. So let's do an example where I go from interval notation to set builder. So we go from, for example, let's say parenthesis 5, comma 8 bracket. So this is interval. How do we get this into set builder notation? Because we're going to be going back and forth in the problems below. So you're going to start with one and get to the other. So if we start with interval, we want to get to set builder. Interval notation basically tells me what the highest and lowest number are. If I were to make a quick little number line, it tells me x is between 5 and 8. X is not allowed to equal 5. But x is allowed to equal 8. And the way to write that in set builder is by putting x in the middle of the lowest and highest numbers. X is not allowed to equal 5, and 5 is on the lowest, so 5 is less than. X is allowed to equal 8, and 8 is the highest, so x is less than 8 because 8 is the highest. And we want to put a little equal bar because we have that. So that's how we go from one to another. Okay, we're going to do a few examples going back and forth from one to another. So in example 1a, you have interval notation, and we want to go back and forth like I said, so we're going to get set builder notation, which means we want to turn this into inequalities. And the easiest way for me to do that is put it on a number line. This shows me that the lowest number is 2, and the highest it goes is infinity. So this is how I make my number line. Basically, x can be anything between 2 all the way up to positive infinity, but can't equal infinity. And that helps me go into Set Builder because now I have a visual. X can be anything greater than or equal to 2. And that's my final answer. And we can see that on the number line that x could be 3, 4, 5, 6, 7, etc. And x can also be 2. Heading to B, I'm going to make a number line again because it's the easiest way, like I said, to visualize. But this time the lowest x can be, and again, it always goes lowest, comma, highest. The lowest x could be is negative infinity. And lowest always goes on the left, highest always goes on the right. Highest x could be is 3. X cannot equal 3. And x will never equal infinity. So that's why those have parentheses. But x could be anything below 3. X can be 2, 1, 0, etc. And so to write Set Builder, because we are going back and forth from one to another, Set Builder involves inequalities, while x can be anything less than, and that was a mistake, not equal to 3. The reason I can't put an equal bar there is because parentheses. Parentheses means not equal to. Heading to C, this time my number line lowest is -2 and my highest is +10. And again, it always goes lowest, comma, highest. X is anything in between. X is allowed to equal -2, but not allowed to equal 10. The way that you'd write this as Set Builder, which is inequalities, would be put x in the middle because x is literally anywhere in between. So I put x in between the two numbers. -2 and 10, lowest goes first, highest goes second. And just take a minute to notice how these things match. X is in the middle, -2 is the lowest, 10 is the highest. I'm kind of putting them in order. And we are allowed to equal -2, but we are not allowed to equal 10. Also, the reason I keep my inequalities in the order that they're in is -2 is lowest, so it is less than, which is why the inequality faces that direction. 10 is the highest, so x has to be less than 10, which is, again, why the inequality faces that direction. We're going to head to D, and this time we're working the other way. We have Set Builder this time, and we want interval, because again, we're going back and forth. So to get interval, I like to make a number line every time. I'm going to make a number line, and I'm going to put -2 on it. X is greater than -2, so I'm going to shade anything on the greater than side, like -1, 0, 1, etc. Those numbers are greater than -2. X can be anything greater than 2 all the way up to positive infinity. And x is not allowed to equal -2 because there's no equal bar, and x will never equal infinity. My interval notation always goes lowest, comma, highest. So I'm going to put -2 first, and infinity is the highest it can be. Both get parentheses, and that's how to answer that question. For E, this time there's no infinities involved because we have a strict range of values that x is allowed to equal. X has to be somewhere in between -3 and 10. X can be any number in between, -2, -1, 0, even maybe a decimal. It doesn't really matter as long as it's in between. So x is somewhere in here. X is not allowed to equal -3 because there's no equal bar. And x is allowed to equal 10 because there is an equal bar. So interval notation is going to be lowest, comma, highest. So -3, comma, 10. Remember, -3 gets the parenthesis, but 10 gets a bracket because x is allowed to equal 10. Last one, and this one's tricky. we are used to seeing x on the left side. So if you want to, you can flip this thing and put x on the left side and 3 on the right side. That's easiest to me because that's what we're used to putting on a number line. And you're allowed to do that as long as you flip, if you're going to flip the x and the 3, flip the sign too. Make sure that if the 3 is on the greater than part, the 3 stays on the greater than part. Okay? So if you flip your whole thing, flip the sign with it. And now it's a little bit easier to see on a number line. I'm going to put a 3 down, and x is anything that's less than 3, like 2, 1, 0, all the way to negative infinity. And remember, x will never equal negative infinity, but there is an equal bar on 3, which means x can equal 3. So interval notation is lowest comma highest, and the lowest is negative infinity. The highest is on the right side, it's 3. We'll never equal infinity, so put a parenthesis, but we can equal 3 in this problem because there's an equal bar, so we're going to use a bracket. In example 2, we're just going to solve inequalities like we would solve normal equations. And then we're going to end up with something that we can put on a graph and write in interval notation. So the goal is to write interval notation for each problem for our final answer. So I have my final answer interval notation all set up, and the goal is to get there. And again, what we're going to do is solve this as if it's an equation. So pretend it's an equation, pretend this is an equal sign. We're going to move everything around the same way we normally would, which means I want to get the variable a or x or whatever it is in each problem by itself. I'm adding 5 to both sides. I get 3a is greater than 12. Dividing both sides by 3. A is now by itself. The sign just keeps going straight down. We don't change the sign. A is greater than 4. 12 divided by 3 is 4. And now this looks just like any of the problems we did in example 1. Let's put a 4 somewhere in the middle, and then 5, 6, 7 on the right, 3, 2, 1 on the left. If a is greater than 4, that means I would shade everything above 4 all the way to infinity. And a does not have an equal bar next to it on 4, so a can't equal 4. I'm going to use a parenthesis because a will not be able to equal 4. And nothing will ever equal infinity. Infinity will always get a parenthesis on it. Remember, we go lowest comma highest when we do interval notation. And you can see what lowest and highest are in the number line because they're in order for you. 4 comma infinity. And remember, both get parentheses because we can't equal 4 and we can't equal infinity. So let's do the next one. In this one, x is on the other side of the inequality, which we're not used to seeing, but I'm going to move stuff around like normal and then go from there. 4 minus 1 is 3. Then we have greater than or equal to 2x. Divide by 2, and you're going to get 3/2 is greater than or equal to x. I told you in example 1 that you can flip these things as long as you flip the sign. So as long as you change the sign to go the other direction, you're welcome to change these to be on opposite sides. And I like that better because that's what we're used to graphing. So I would write it like x is less than or equal to 3/2. And by the way, 3/2 as a decimal is 1.5. The reason I write it as a decimal is sometimes decimals are easier to put on a graph. So I'm going to say x is less than or equal to 1.5, which means that on my number line, I'm going to put a 1 and a 2 because 1.5 is right in the middle. And x is anything less than 1.5, and x can equal 1.5 because we see this equal bar right here. If x is anything less than that, then we're headed all the way past 0, past -1, forever to negative infinity. And we can never equal negative infinity. So when we write our interval notation, which is the goal is to write it in lowest, comma, highest. Well, the lowest we can be is negative infinity. You can see that on the left side. And the highest we can be is 1.5. And we are allowed to equal 1.5, so I would put a bracket there. This would be my final answer. Last one for this example, and the only tricky part about this one is we have a fraction attached to our variable. But I'm just going to go step by step, getting rid of one thing at a time. I'm going to get rid of the denominator first. And the way to get rid of a denominator, because it's division when it's a denominator, is to multiply. Multiplication cancels division. And now I have 2b less than -12. Now this is a simpler problem. I just divide by 2 on both sides, and I've got b is less than -6. And if b is less than -6, then that means I put a -6 anywhere I want in the middle of my number line, and then I fill in some numbers surrounding it on both sides. But I want to shade the stuff that is less than -6. And numbers that are less than -6 go even lower than -6. They go down towards negative infinity. And that's the side I want to shade. I want to shade the left side. The left side is the less than side. We can never equal negative infinity, so I'm going to put a parenthesis. And we can't equal -6 either because there's no equal bar there. So I'm going to also put a parenthesis. My interval notation is going to be lowest, comma, highest, using parentheses or brackets. And in this case, it's parentheses on both. In example 3, it's the exact same type of stuff, but there is a rule that you do need to know. Anytime you're working at an inequality where you're solving like we normally do, like we did in example 2, you have to be really careful of one thing. If you multiply or divide by a negative number on both sides, then you are going to have to reverse your inequality symbol. So I'm going to do an example of that just to show you what happens if you multiply or divide by a negative on both sides. And I would like to show you guys this rule about multiplying or dividing by a negative. So what I'm going to do is I am going to move my -7 or my 7x over to the other side by subtracting 7x on both sides. It doesn't really matter which x you move where, as long as you get your x's on one side together. But again, I'm going to show you this special trick, so I am doing it this way. The next thing I'm going to do is get rid of the +8 by subtracting 8 on both sides. And I have -3x is less than or equal to 3 minus 8 is -5. My last step here is dividing by -3, and this is the part you have to be super, super careful about. Because remember, when you multiply or divide both sides by a negative, your inequality symbol reverses. So I multiplied or divided by a negative on both sides, and therefore I have to switch this sign. And that's the rule I wanted to show you. And that will happen anytime you do that to both sides. If you divide by a negative or multiply by a negative on both sides of your inequality, then you need to flip your sign. And that leaves me with x is greater than or equal to -5 divided by -3. Well, my negatives cancel because a negative over negative is positive, and I'm just going to leave this as 5/3. But to put this on a number line, it might be easiest for you to round to a decimal. And 5 divided by 3 on a calculator rounds to about 1.67, which means that I'm going to put a 1 and a 2, and I know that 1.67 will go right in between somewhere. Now I'm all set to shade and write my answer in interval notation. So if x is greater than 1.67, I'm going to shade everything above all the way to infinity. X is allowed to equal 1.67, but x will never equal infinity. So my interval notation, which is my entire goal, is going to be, you can put 1.67 if you want to, but now that I already have it on my number line, I'm going to go back to 5/3. 5/3, which this is 5/3. 5/3 is the lowest, infinity is the highest. That's my final answer. Make sure you use a bracket next to 5/3 because you're allowed to equal 5/3. E is the last problem I'm going to do from this example, and the reason E is a little bit different is you have two signs, and whatever you do to one side you want to do to all sides, but this time you have a left side of an inequality, a middle, and a right side. So whatever you do to the left side, you're going to do to the middle and the right. You have to do the same thing to all three sides. And the goal is to get n in the middle alone. We want to get rid of the 9, we want to get rid of the 2, and we're going to solve it like a normal equation, other than the fact that it does have to be all three sides that we deal with when we solve. So if I subtract a 9 from the middle, I need to subtract a 9 on the right and on the left, which leaves me with -10. Bring your sign down with you every time. My 9 minus 9 went away, so 2n is the only thing left in the middle. Bring your sign down again. 17 minus 9 is 8. You have one last step for getting n totally by itself, which is the goal, in the middle. You have to get rid of the 2, and we're going to divide by 2. When you divide by 2 in the middle, you have to do it on the right, and you have to do it on the left. Remember, you're allowed to divide by a positive number without flipping any signs, but if you divide by a negative number, you will have to flip signs like we did here. When we divide by 2, we get -5. Bring the sign down with you, and the 2's cancel in the middle to make just an n. Bring the sign down again, and 8 divided by 2 is 4. And what this tells me is that n is anywhere between -5 and 4. I also noticed that there's equal bars, so n is allowed to equal those things. On my number line, if I were to put a -5, I would not make it all the way up to +4. There's not enough space. So on this particular number line, I'm actually going to go by 2's so that I have enough room, because otherwise I won't fit everything. And now I can get from -5, which would be right here, all the way to +4, which would be right here. And n is allowed to be anything in between those two numbers. So I want to shade all the in-between stuff. N is allowed to be -5. N is allowed to be +4. My interval notation, which is my goal, will go lowest, comma, highest. -4 is the lowest. I'm sorry. -5 is the lowest, and +4 is the highest. We are allowed to equal those values, so we put brackets. The very last example is going to be pretty quick because what happens in the last example is we're going to do the same steps, but you're going to notice that x or whatever variable you use will cancel completely on both sides and you won't have a variable anymore. When that happens, which is rare, but sometimes it happens, you are going to have one of two options. You will either have infinitely many solutions or no solution. And let me give you an example of each one. Infinitely many solutions would be a situation where x is gone completely and you have a statement that is true. For example, 1 is less than 2 is a true statement because 1 is less than 2. So it's true. That would be infinitely many solutions. An example of no solution would be something that's false. Like, for example, 1 is greater than 2. That's false. 1 is not greater than 2. If you have $1 and your friend has $2, they have more money than you. You do not have more money than them. So we're going to find out what each one of these is by trying to solve like normal. And you won't be able to tell if it's going to be a special situation like infinite or no solution until you try solving. So let's try solving, and we're going to do it the normal way. We're going to distribute. We're going to pretend it's a normal equation. We've got negative 6x for our first term from distributing here. Negative 3 times negative 5 is positive 15. Then we bring our sign down with us, and we have negative 6x plus 9 on the other side. And what you're going to notice is that if you try to get all your x's together, they actually cancel completely on both sides. And you end up with a statement with no variable whatsoever. 15 is greater than 9. You're asking yourself, is this true or is this false? Because if it's true, it's infinite solutions, but if it's false, it is no solution. Well, 15 is greater than 9. That is a true statement. So this would be infinite. And the very last one, it's going to be the same exact process. Solve it like normal. On the left, I have 4x minus 5. There's nothing to do there. But on the right, I get 2 times 2 is 4x. And then 2 times negative 3 is minus 6. Well, same situation. If I try to get my x's together by subtracting on both sides, they're actually gone. And I'm left with negative 5 is less than negative 6. You have to ask yourself, is that true or false? Remember, if it's true, it's infinite solutions, but if it's false, it's no solution. And if you think about a number line, negative 5, negative 4, negative 3, etc., all the way up to positive infinity. And then on the other side, you have negative 6, negative 7, etc., all the way to negative infinity. Negative 6 is less than negative 5. It's further negative, so this would be false. And that means we have no solution. And really what these mean are, heading back to the first one, if you have infinite solutions, that means that no matter what number you plug in for x, you're going to get a true statement at the end. You can plug in anything you want and it's going to be true. But for b, you can plug in anything you want and every single time it's going to be false. And so the last thing I want you guys to do is write down your summary and use OneNote to do that, because there's a good chance that there's a summary already written out for you on OneNote. If not, you need to make your own summary, but you do have to fill in your summary.